Hey, welcome back to our Java programming tutorial, part 3 now, where we'll talk about different variable types and typecasting, working with different data types and more complex calculations. So this is where we left off. If you remember, um, we had this error because we tried to add a integer value to a double value and save it into another integer value, which won't work because we'll lose some data here, and Eclipse was smart enough to tell us about it. So, well, the obvious solution, of course, is that we don't want an integer second result, we need a double second result. This will fix it, and the result will be whatever the result will be. But that was quite easy. However, sometimes it's more tricky um, because we don't always see that we actually lose some information, and Eclipse doesn't always tell us either. Because, well, what Eclipse does is it sees what data types you work with on the right hand side here, and it sees what data type you have available to save to on the left side. Um, but sometimes it's not as obvious. So, for example, um, let's say we got two integer values. Our first, which is 4, and let's say we have our second, which is 3. Um, and what we want to do is we want to save the result into an integer value third. And we want to do a division. We want to divide 4 by 3. So now what? Well, first of all, don't get confused by those warning signs and the underlining, the yellow underlining. Um, it'll just tell us that the value of the local variable is never used. So, okay, first of all, this is first through second. Um, but we never do anything with third, our second result, our third number. We never used them anywhere. So he's kind of trying to tell us, um, hey, you don't really need that. Why don't you get rid of it? So don't get confused. So what happens now? I mean, if you think about it and divide 4 by 3, you you know that the result is 1.3 period. And well, the thing is, we try to save it into an integer value, so we don't actually have all those numbers here available actually because they're after the decimal separator. Um, so what will actually happen? Um, well, the thing is, you will first of all do a basic calculation over here. And then he'll save it to the integer value. So let's just look at what it will give us. We'll just print third, and let's just comment out our other console output so we don't get confused. Let's just run it, and it's 1. Okay, so um, it just rounded it down. You might think, and it was kind of to expect, right? Um, because, well, obviously it can work with the values after the decimal separator, so it just runs down. But let's say we take 4 through 2.5. Okay, that didn't work. Let's say we divide 10 by uh, by 4, which should be rounded up, right? Because it's to 0.5 and 0.5 you round up. Okay, let's try that, right? We manipulate the values so that it's 10 and 4, and then we'll run the program and we'll save it. And what you can see, well, it didn't round up because it doesn't really care. It just knows you can't fit it in there, so everything after the decimal separator is being thrown away. So that's good to know, because for us that means we can't work like that. If we know we don't need anything after the decimal separator, uh, we want to have it rounded, we can't work like that. So what happens if we have a double value, fourth, or let's just say, okay, so we don't want to lose the value. Um, uh, well, everything after the decimal separator. So let's just make it a double, right? I saved, and I run, and what do you expect to come out? I mean, it's a double value, so it can save 2.5, and if we run it, it comes out with 2.0. So why is that? Well, the thing is, when doing calculations, um, it doesn't. Well, first, it works in two steps. The first one is whatever's on the right side will be, well, executed, so to speak. We'll do the basic arithmetic calculation. Then, only then, after that's finished, he'll look at what's on the left side, and he'll then save the values to the left side, and then he will do whatever adaptation is needed to save the data type. So that's what we saw when we had integer here. He did the basic calculation on the right side, and then, as you can see, 2.0, even if 2.0 was the result, he saw, okay, you can't fit 0.0, so he'll just save 2. Okay, but why doesn't it work now? Well, the thing is, on the right side here, he works with two integer values. So the program thinks, well, if I calculate something with two integer values, the logic result must be an integer value. And, well, it works with all basic calculations. If we multiply, it works. If we do, and if we work with plus or minus, it works. But it doesn't work when we work with divisions. So we would actually have to work with double values. Um, so now let's say, well, we could easily change these to be double values. But in other usage cases, we might not be able to do that. We might just get integer values from someone else we work with. And, well, what we're going to do is called typecasting. And typecasting is basically what um, what Java does itself when we work like this and have an integer here, because it and we have, for example, when we have double values here, the compiler it sees, well, there's an integer value on the left side, so he typecasts the double value to be an integer value. And we can also do that manually, and it's always good practice to do that manually, because you can, even if you think the it will be typecast the way you want it to automatically, you can never really be sure. There's always an inherent risk that in some way it works differently from what you expect. Um, Even, for example, another usage case would be if we defined pi. Define. It's of course it's a double value. It's pi equals 3.1. Let's 1 for 1. That's enough for us. And Well, you usually work with 4 and 3 if you want to calculate something um, based on a circle. And now what happens is um, 3.14. So as you can see, it didn't use 1.3 period, what would actually be the result, even though there is a double value involved. It simply uses the double value times 1. Why? Because um, every calculation is a step-by-step calculation. So it doesn't understand that there are two integer values and a double value. It starts from left, goes to the right, and it only sees two integer values, which would be an integer, 1, and then there's a double value involved, and that'll be fine, and it will create a double value. So another usage case where you might have thought, well, that would work, there's a double value involved, but, well, it doesn't work. So it's always good practice to do typecasting yourself. And typecasting is rather pretty easy. It doesn't work in all cases, we'll see that later on, but in our basic examples it will work, and we'll simply tell the variable, put it in these brackets, and we'll tell the variable, hey, why don't you turn into a double? And as there's an order of how strong the bindings are. Um, so the usual multiplication and division is stronger than plus and minus, and usually we go from left to right, but um, typecasting is stronger than any multiplication or division. So what will happen is that we'll first have a typecast here, put second to double, and then we'll have a typecast here, which will, okay, we're gonna go from left to right, so we have a first is going to be cast to double, and then second, and then we have the division, which will then not be 1, but the actual result we want. Well, we always lose after a certain number of digits after the decimal point. We will lose some values because it can't save an endlessly long number of digits. But well, this is really what we'd expect, 1.333 something. So this worked, and it's basically the same thing as if we just, instead of 4.4 divided by 3, we could also just write 4.0 by 3.0. So if you are able to work like that, you should always declare the variables the right way beforehand. But if you don't know in what way to use them later on, or if you can't change the values you get, or you can't, make a decision what type they have, you will always typecast. And we can also go the other way around. So let's say we have a double fourth, and then we have the two numbers 3.4 and 3.5. We can just go ahead and cast them to integer ourselves, which, no, even though we have a double value available, which means the compiler wouldn't cast themselves, we will just be able to say fourth, and we'll save, and it will be made an integer here, and then it'll be made back to double there, and then we'll have a double value here, which is the result of those two integer values. So what it'll do is it'll just throw away these two digits here. And that's it for today. Next time we will talk a little bit more about different variable types, data types. We'll use text. We will also will create more complex output in order to tell our user what exactly we are doing, and not just work with random numbers and put them out. Hope you liked it. Make sure to tune in next time, and we'll see you soon.